This is lesson 1.3, Solving Systems by Elimination. In the previous lesson, you learned how to solve two equations that have two variables by graphing. Graphing is great when they provide you a graph and the numbers are small. In this lesson, the objective is to learn how to solve x and y just by looking at and manipulating the equations. Basically, you're solving both of them at the same time. So you will do this in 5 steps. So here's your recipe for solving systems. The first step is that you will remove fractional coefficients, or just any fractions that are in the equation. Even when you're solving linear, just single equations, you can do this at the very start. Your teacher may not have shown you this before. It does make the numbers a little bit bigger, but if you are not comfortable with fractions, this step is great. So I'm going to demonstrate it for you. When you see an equation that has a fraction in it, look at the denominator of the fraction. If they are the same, you can do this quick little trick. What you will do is multiply the entire equation by that denominator. Now, I wrote the whole equation. I put parentheses around the entire equation, equal sign and all, and I put 19 on the side. Now, it does not matter if I write it on the left or the right. I will distribute or multiply every term by that 19. So, let me draw an arrow to show the result of multiplying it by 19. So 19 times 1 is obviously 19, plus, and here's the purpose of this trick. Whenever you multiply a fraction whose denominator is the same number that you're multiplying by, they cancel each other out. That 19 will cancel out the 19, and you're just left then with the 7x. Then you multiply the 19 to the final term, even though it's on the other side of the equation. Don't forget to write the equal sign though. So 19 times, that's a negative 1 over 19. Because the number that we're multiplying is the same as the denominator will cancel out, and you're just left with negative 1y. Or negative y. You do not need to write the 1 there. Doesn't that equation already look much simpler because we got rid of those fractions? Now, when you are doing this step, if the other equation does not have any fractions to it, we will simply just rewrite the whole equation right underneath it. You're going to find out when you're solving these systems that you always want your equations to line up underneath each other to prepare yourself for the next step and the next step. Alright, step 2 is convert any equations so that they are in the same form. Now, it really doesn't matter which form you use. It can be standard, it can be slope-intercept form. The main goal, though, is you must have your x terms in the same position, the y terms in the same position, your equal signs in the same position, and your constants in the same positions. It doesn't really matter the order of them, but if you are looking up for more practice on systems of equations, most textbooks and online will always have you go to using the standard form. So let's remember what the standard form looks like. In standard form of an equation, you will have your x term plus or minus your y term equaling whatever your constant is, that number that doesn't have any variable. And even though you have your x and y term, there could be a coefficient or a number in front of those x and y term. So that's your standard form. Slope-intercept form is the form that you used whenever you were graphing. That's when you used y equals mx plus b. That's when you had your y term on the left-hand side of the equation and your x term on the right-hand side of the equation with your constant, which in this case was your b value, or slope-intercept form. So just as long as you make sure that the equations are in the same form, or at least the variable terms are in the same position, so are the equal sign. So let's take a look at an example. I'm going to go ahead and put these two equations in standard form. The first equation, if you notice, we have x plus or minus a y equaling a constant. So that equation is in standard form. The second equation is in slope-intercept form. So let's change that so that it is also in standard form. Standard form, you just need to make sure your x and y variable terms are both on the left-hand side of the equation. We have to move that x term to the other side of the equation. So what do you need to remember to do? If you change the side of the equation, you have to change the sign. Sign being positive or negative. So you would write negative 5x plus y is equal to 6. Now if you're wondering where did that plus sign on the y come from and where the plus sign go on the 6, remember that if a term is not the first term in an equation, you must write the sign, regardless if it's positive or negative. Because we moved that 5x to the other side of the y, that y became the second term on that side of the that expression. Therefore, we had to put the plus sign there. The 6, because we left it all by itself, and because it was positive, it is the leading term of this expression on the other side of the equation. That's why we don't need to write the plus sign on it. Okay, the top equation, we're not going to change. It's already in standard form. But I am going to rewrite it, just like I showed you in step 1, to make sure that our equations are lined up with each other. All right? So the goal of step 2 is to make sure that your x terms are in the same position, your y terms are in the same position, your equal signs in the same position, and so your constants. Basically, that both equations are lined up with one another, or in the same form. Alright, so I'm just breaking down and showing you each step. We're ready for step 3. When we're all done with all 5 steps, I will actually just take one problem and we will do all 5 steps to that problem. In step 3, your job is to eliminate 0 paired variable terms, or basically make 0 pairs and then eliminate them. It's another way of saying that. Now look at our 4 scenarios here. I want you to compare these systems and see how they're alike and different. In scenario 1, you have 2x over your 4x. You have positive 3y over negative 3y. Your equal signs are lined up, and you have a 4 over a 2. So these two equations are both in the same form. They both happen to be in standard form, and our variable terms are all lined up, our constants are lined up, and so is the equal sign. So step 2 has been done for us. Now, what this means by the scenario is what you're doing is looking for 0 pairs. In this equation, we have a 0 pair. Do you guys recognize it? Do you remember what it means to be a 0 pair? A 0 pair means that the numbers are exactly the same for the same variable. So in this case, we have the variable y that both have the same coefficient, the 3, but one of them is the opposite sign. So you have one that's positive and one that's negative. We have a positive 3 and negative 3. Now, they could have been the other way around. The top equation could have a negative 3 and the bottom equation could be a positive 3. So there we've identified a 0 pair. That's what we're looking for. So the whole purpose of the elimination method is that you are trying to eliminate or get rid of one of the variables, find out what the value is of just one variable, and then eventually you're going to plug it back in. Because we have this 0 pair, we have just eliminated a variable. We know that positive 3y plus a negative 3y would equal 0, so they're gone. In scenario 2, let's look. Do we have any 0 pairs? We don't. The coefficients of x's are 2 and 5. The coefficients of y's are 3 and 6. But we do have opposite signs. Do you see that? Look at your y term again. You have a positive 3y and a negative 6y. So I want to point this out because when you're trying to eliminate a variable or trying to choose which variable that you're going to attempt to eliminate, if you're halfway there, then use that variable. What I mean by that is that, okay, we already have opposite signs, but we don't have the same coefficient, the same number. So now we need to make them the same number. The way that you can do that is multiply each equation by the opposite coefficient, just its absolute value, just the number. So what I mean by that is just like in step 1 when we multiplied an equation by a number, whatever the coefficient of the variable we're trying to eliminate, so we're trying to eliminate y, the second equation, the coefficient, the absolute value is 6. So I'm going to multiply my top equation by 6. My top equation's coefficient, just the absolute value of it, is 3. So I'm going to multiply my bottom equation by 3. Notice the top equation, I'm not multiplying by -6. It's just the absolute value, which means just the number without the sign, just a positive value. We will be eventually multiplying by negative numbers. That's in another scenario, and I'll explain why later. So now that I know what number I'm going to multiply by, I will simply multiply every term by that number. Just kind of like in step 1. So I multiply the top equation by 6. 6 times, and you're using your distributive property. 6 times 2 is 12x. Don't forget your variable. 6 times positive 3y. Notice what I'm doing. I'm not writing plus and then multiplying and writing down my answer. I'm waiting until after I multiply to write my answer and its sign. 6 times positive 3y is positive 18y is equal to 6 times, what am I going to multiply? Did you say 4? 6 times 4 is positive 24. Okay. Now we're ready for the bottom equation. I'm going to multiply that 3 to every term. 3 times 5x is 15x. 3 times -6. Do not forget that sign there. 3 times -6 equals -18y is equal to 3 times 7 is 21. Look what happened when I multiply by the opposite coefficient. I just made a zero pair. So that's what I mean by making a zero pair. If you already have opposite signs, you can simply multiply by the opposite coefficient. There is one other method of doing this that will result in smaller numbers, but it doesn't work all the time. And if you do not know your division and your multiples very well, then I strongly recommend just using this, multiplying it, and it works every single time. In scenario 3, let's compare those equations. How is this alike or different from our previous 2 examples? Do we have any zero pairs already? No. But I can tell you we do have coefficients that are the same. What ones are they? Look at your variables. Do you notice the x's? What's the coefficient of both those x's? You say 1. They're both positive 1. So kind of like scenario 2, we are halfway there. We have the same number, but we don't have opposite signs yet, so we can't eliminate. I see many students do this time and time again. They go, oh, look, it's the same number. They eliminate. You have to remember they must be also opposite signs. So in this scenario, what you will do is simply multiply one of the equations by a negative, or think of it like multiplying by -1. When you multiply any equation or anything by a negative, it simply changes the signs of every term you're multiplying by. So if I multiply a negative to a -1x, I get -1x. If I multiply, that was that one. If I multiply a negative to a positive 3y, I get a -3y. is equal to, if I multiply a negative to a 2, I get negative 2. Because I'm not changing anything to the top equation, I will simply just copy it down. Positive 1x plus 2y is equal to 3. Do you see your zero pair now? Right there. So those two variables terms will eliminate from each other. Alright, so let's look at scenario 4. It's kind of like the combination of both, your worst case scenario. For your worst case scenario, when you have neither one of your numbers are the same, neither one of the variable term signs are opposite of one another, then we have to decide, okay, I have to do both things. I not only have to multiply both equations by the opposite coefficients, but I also have to multiply by a negative. You also need to choose, okay, which variable do you want to eliminate? It will work regardless which one you choose, but just a helpful word of advice, I would always choose the variables that have the smaller coefficients. It'll be smaller numbers that you need to multiply, and you can usually do the math in your head. So looking at the two equations, I have x, the coefficient of 1 for my x over a 4, and a 2 over a 5. Well, 1 and 4 are smaller than 2 and 5. Let me go ahead and write that 1 in. You might want to do that if you ever see a variable that you don't see the coefficient, go ahead and write the 1 in just so you can see it. Alright, so I'm going to choose to eliminate my x terms because the coefficients are smaller. So just like in scenario 2, I multiply by the opposite coefficient. So I'm going to multiply the top equation by 4 and the bottom equation by 1. But I also want to create opposite signs, so I need to make one of them a negative. You'll notice when I do this, I generally will always choose the bottom equation to make negative because, I don't know, they kind of look like subtraction problems then later on. It makes it a little easier. Alright, so let's multiply that top equation by positive 4. Let's see if you can say it as I'm working. What would the answer be? 4x plus 8y is equal to 12. See, we multiplied every one of those terms by positive 4. Try the bottom equation. You're multiplying everything by negative 1. Remember, when you multiply by negative 1 or just a negative period, you will change every sign. Negative 4x minus 5y, or negative 5y, is equal to negative 6. So we just changed all the signs. When you multiply 1 by anything, it's just itself. That's why the coefficients didn't change their numbers, their absolute values. Alright, where's your zero pair at? Right there. Okay, so you will have those 4 different types of scenarios when you're eliminating your variables. In step 4, when you're solving systems of equations, after you've eliminated your variable, in this case, or eliminated your zero pair, then your next step is to combine the two equations together. You're going to be combining like terms. And remember, when you combine like terms, we use the rule of SOB. If the signs are the same, then you add. If the signs are opposite, you subtract. But the bigger sign always wins. Those are the rules of adding integers. So let's combine the 2x and the 4x. Those are both the same sign, so you have to add 6x. The variable stays the same when you add terms together. The bigger sign wins. They're both positive, so it's going to stay a positive 6x is equal to, now let's combine our constants together. They're both the same sign, so we have to add 4 plus 2 is 6. So we combine and solve. After you've combined it, then we're solving for x. It's just a matter of isolating your variable from its coefficient. We have a 6 that's beside our x. If it's beside it, you always divide it. You'll hear me rhyme quite a bit. I like to rhyme. Helps me remember what to do. So if it's beside it, I divide it. X is then equal to, because those 6's cancel out, 6 over 6 reduces to positive 1. Alright, remember when we're solving systems of equation, we have an x value and a y value because we need to find the point where these two lines intersect. So we're only halfway there, but we are almost done. We're 4/5 of the way done with the problem. The fifth and final step is to plug our known value, the value that we just solved for, the x, into one of the original equations, not one of the ones that we modified. So when choosing, it doesn't matter which equation you plug it into, it will work, but to make your life easier, again, I would choose the equation that has the smaller numbers. So if I look back at the equation that I had here, let me erase so you can see it. I would in this case choose my top equation because the numbers are smaller. The 2x plus 3y is equal to 4. So in step 5, what you're doing is whichever value that you just solved for, by the way, you won't always get x first. Sometimes you'll get the y first. You will replace the x variable with the value. So I'm going to rewrite this. 2 times 1. Notice that when I plug in a value for a variable, I put it inside parentheses. Otherwise, it'd look like the number 21, not 2 times 1. 3y is equal to 4. So I plug it in and then solve for the other variable. So I need to simplify it. 2 times 1 is just 2 plus 3y. I'm just going to recopy it down. Simplifying the equation and solving for that other variable, the y. Alright, looks like I got a two-step equation now. I have a constant and a variable term, and I need to get that variable all by itself, so I need to remove the constant or combine my constants together first. You should not be dividing by 3 first. There's a 0 pair, so it eliminates. I'm left with 3y is equal to 4, a positive 4, and a negative 2. This is the same thing as saying 4 minus 2 is just 2. And I'm going to pause here because I think I made a mistake. Okay, it doesn't look like I made a mistake. I just was doubting myself because I know that the answer is going to turn out to be a fraction. It's just because of the equations that I chose, but all your problems on any of your practices and your homework and stuff, I don't believe I have any point that ends up to be a fraction. So if you don't get whole numbers, then you can go back and check and make sure you've done the problem right. So 3 over 3 cancels out, so I'm left with y is equal to 2/3. So I got a fraction. It doesn't reduce. I just leave it as a fraction, 2/3. My final answer, remember that the answer to a system is a point, and you always have to write your x variable before your y variable. So I'm going to write 1, and in this case 2/3. It's just the way the problem turned out. Okay, I've demonstrated each step to explain them to you, but let's put it all together and actually look at your guided practice problems. So pull out your guided practice 1.3 and we're going to do the problems together. I'm going to do one and do all 5 steps with you, and then give you the opportunity to do one, get as far as you can, and then I will show you the answer. Alright, we are looking at problem number 1 on the 3.1 guided practice. Up in the corner here, I put down the 5 steps, kind of a little short note for you to remind you of the 5 steps that we're going to be applying. Removing the fractions, making sure that they're in the same form, make 0 pairs so that you can eliminate them, combine and solve, and then plug it back in and solve for the other variable. So let's do all 5 steps to a problem to solve it. Looking at the problem, do we have any fractions? Nope. So we're done with step 1. Step 2. Are both equations in the same form? Yes, they are. We have our x's over x's, y's over y's. Very important, our equal signs in the same position, and there's your constant. Sorry, that's a lot of circles there. So they're both in the same form. We're ready for step 3. Make 0 pairs. Well, look to see if you already have 0 pairs before you try to make them. Do you notice the 0 pair? Is it our x terms or our y terms? Those y terms are 0 pairs, because remember, if you don't see a number, the coefficient's 1, so we have a positive and a negative 1. That's a 0 pair. That eliminates. So we're done with step 3. Step 4, combine and solve. So let's combine these two equations together. We have a positive 8x and a negative 5x. What does that equal? Did you say positive 3x? Yeah, those are opposite signs, so you have to subtract. Is equal to 5 minus 2 is 3. What's our next step? Because that 3 is beside it, we have to divide it. Divide both sides by 3. 3's cancel. So x is equal to 3 over 3 reduces to 1. Okay, so we're finished with step 4. We're ready for step 5. Plug it in and solve. So we have to plug it into one of our original equations. I'm going to kind of erase here so we can see what those were. And in my opinion, I would choose the bottom equation, smaller numbers. So I'm going to rewrite the same equation, 5, and it's x, but we know what x is equal to, so we're going to replace the value for the variable. Plus y equals negative 2. So we plugged it in, and now we're going to solve for the remaining variable. We need to simplify. Negative 5 times 1 is negative 5. You're multiplying, you're not adding, so it's not the SOB rule. Plus y is equal to negative 2, so I just recopied the rest of the problem. And I'm adding 5 to both sides so that I can get that y all by itself. Y is then equal to positive 3. So your final answer, remember, don't stop right there. Your final answer is 1, 3, like that, inside parentheses. Problem number 2 is very similar to the one we just did. I want you to go ahead and try it. Get as far as you possibly can. Push pause while you're working on it, and then push play when you're ready to check. If you get stuck along the way, you can push play and see if you're on the right track. Alright, let's see how you did. You notice that there was no fractions, so you do not need to eliminate fractions. Oops, sorry, just a second. Okay, there we go. You notice that they're both in the same form, so we're done with step 2. My screen is going all over the place. Just a second. Step 3, make the 0 pairs. You already have a 0 pair that can eliminate, so we don't really need to make them. We just need to eliminate them. You're ready to combine and solve. You have a positive 4y and a negative 1y, so that is a positive 3y is equal to. Now look at this. I can't tell you how many students I see that just do this, and they go, okay, I don't know what I'm supposed to do now. It's 3y. Well, you're still combining the constants together. What is 6 combined with negative 6? Yes, it's a 0 pair. That means when you combine it, it equals 0. So you're not quite done yet. 3 times y, so you divide by 3, y is equal to 0. Okay, you can get a value of 0. It's okay. I get so many people that get stopped so early on just because they don't think 0 can be an answer. Alright, we're ready for plugging and solving. So, I need to choose which equation I'm going to plug it into. They both look okay. I'm going to go and use the second equation. So, negative 2x minus y is equal to 0 is equal to negative 6. Alright, So if you subtract 0 from anything, it's like doing nothing to it. You can just cross that off. So I have 2x is equal to negative 2x is equal to negative 6. Well, I have a negative 2 that's beside my x, so if it's beside it, I have to divide it. Remember when you're dividing that the sign goes with it. You're not changing the sign when you isolate a variable. So x is equal to negative 6 over negative 2. What does that reduce to? Well, a negative over a negative is always a positive. I know we don't need to write the sign of the positive sign. Just doing that to make sure you remember it. 6 over 2 reduces to 3 over 1, or just 3. Alright, now we're ready to write your final answer. Ooh, let's be careful. Make sure you didn't make this one little mistake here. Did you write it as 3, 0? How many of you wrote 0, 3? Remember, x's come before y's always in an ordered pair. So just because we found out what y was equal to before we figured out what x is equal to, doesn't mean you write it in that order. When you write an ordered pair, you always write your x before your y. Okay. Okay, sorry, I had a message pop up. Stop the recording. Let's go ahead and try number 3. I'm going to do it with you, and then you do number 4 on your own. Alright, the first thing that pops up on my mind when we look at problem number 3, ew, fractions. That's step 1, remove that fraction. Okay, so how do we remove a fraction? You multiply the equation by the denominator of the fraction in the equation. So I multiply every term by 2. Negative 7 times 2 is negative 14. Don't forget those signs. Positive 2 times the 1/2 is equal to positive 1y. All we're doing by multiplying by 2 is canceling out the 2 on the denominator. That was the whole point of doing this. Is equal to 2 times x is 2x. If you ever need more time to write, then just please push pause, finish writing before you push play and finish listening. I don't want you really to be writing and trying to listen at the same time. The top equation, we're not changing at this point, so I'm just going to recopy it. 19 plus x equals 2y. Sorry, it's not that easy writing with a stylus if you've ever tried it before. Alright, so we did step 1. We removed the fraction. Now we need to ask ourselves, are they in the same form? Well, look at this. We've got a constant here and a constant here. You have an x term here and an x term over here. And, I need another color here. You have your y term here and your y term here. So this is obviously, these equations are not in the same form. We need to reorder them. I'm going to go ahead and use standard form. So for equation 1, I'm just going to write equation 1 because I have to write it down here. I need to move, it looks like I need to move my y term to the left-hand side of the equation, and I need to move my constant to the right-hand side of the equation. Whenever you move a term from one side of the equal sign to the other, all you need to do is change its sign. So the x term, we did not switch sides. We're going to just like push it over a little bit, but we are not changing its sign because we didn't change the side of the equation that it's on. It's still on the left-hand side of the equation. Move my 2y over as a negative 2y. It was a positive, now it becomes a negative because I had to switch the side of the equation. Is equal to negative 19. So that's how we can rearrange an equation. Just knowing that if you move that term to the opposite side of the equation, you have to change its sign. Let's see if you can do it for your equation 2. What is the value of my x term that needs to be right underneath the other x term? Well, it was a 2x, so I need a negative 2x to get it on the left-hand side of the equation. And then I need my y term. My y term is already on the left-hand side, so I just get to keep its sign. Just copy it down. Is equal to, now I need my constant, the negative 14. I need to bring it over to the right-hand side of the equation. So it is a positive 14 now. Alright, so check. I'm done with step 2. I have them both in the same form. I'm ready to make 0 pairs. Do I have any? No, I don't have any numbers that are the same in front of any of my variables. By the way, when we're looking for those 0 pairs, it's the 0 pairs of the variables, we're not looking at the constants here. Even if those are 0 pairs, that's not what we're trying to make into 0 pairs. They might be 0 pairs like in one of those previous examples, but we're looking at the variables. Alright, do we have a variable that is halfway there at least? It looks like both of them are, because both are x variables. There's a positive and a negative, and our y variable has a negative and positive. They're also opposite signs, so it does not matter which one we choose at all. And because they're the same numbers, it really doesn't matter. So just, I guess, look at them and say, okay, which one do I want to eliminate? I'm going to choose, oh, let's go with x this time. Let's get rid of our x's. So to get rid of my x's, I have to multiply the equations by their opposite numbers. That was a 1, so I need to multiply the bottom equation by a 1. The bottom equation has a 2, so I need to multiply the top equation by a 2. I do not put a negative anywhere in the number that I'm multiplying because they already have opposite signs. Alright, now I use my distributive property and multiply. 2 times 1x is 2x. 2 times negative 2y, don't forget that sign there, is negative 4y, is equal to 2 times negative 19. Oh, it's late. Grab a calculator if you'd like to. I'm going to. Because it's a negative times a positive equals a negative, and 2 times 19 is 38. Our bottom equation, we're multiplying by 1. Remember when you multiply by 1, it equals anything you're multiplying by? So everything just stays the same. Negative 2x plus 1y is equal to 14. Alright, and so we made our 0 pair. Let's go ahead and eliminate them. There's our 0 pair. Now we're ready for step 4, combine and solve. Alright, negative 4y and positive y equals negative 3y. Remember, bigger sign wins. 4 is bigger than 1, and it's negative. That's why it's a negative. Negative 38 and positive 14, those are opposite signs, so you have to subtract. Equals 24. Again, don't forget, bigger sign wins, so it's a negative 24. We're solving for y now, so we have to isolate the variable. We have a negative 3 that's beside our variables. If it's beside it, we have to divide it. Y is then equal to, well, negative over a negative is a positive. 24 over 3 equals 8. Right? So we've combined and solved. One last step to go. Plug it back in. So choose one of the original equations. Hey, take a guess which one I'm going to choose. Regardless how big the numbers are, I'm going to choose that equation that does not have any fractions in it. 19 plus x is equal to 2 times the y value, which we said was 8. Alright, let's solve for x. Simplify this and we'll get 16 is equal to, let's see, the x plus 19 here. To get x by itself, we have to subtract 19 from both sides. Oops, dropped my pen. X is equal to a negative 3. Alright, write your final answer. Negative 3, comma 8 in parentheses. Right? You try number 4, push pause until you're done, and then push play to see if you got it right. Alright, I did problem 4 all the way out. I will rewind to show you the steps, but look at your final answer and just see if it's right. If it's right, you can fast forward to where I start talking about problem number 5. If you missed it, then keep watching and I'll rewind and show you how I got the negative 9 and negative 7. You can see where you made your mistake. Alright, let me back up my work here. This is fun. Alright, looking at the two equations, did you notice that you had a fraction, so you needed to multiply that bottom equation by positive 2 so that you can get rid of the denominators? So that's all I did, is I multiplied the equation by 2. Remember to multiply every term by 2, even the term after the equal sign. That's the one that seems to always be students forget to do. The top equation I just recopied. Alright, and then I noticed that I've removed the fraction, but then I asked myself, are they in the same form? Well, let's take a look at this. Our x's are above our x's. Oh, I guess I was going to tell you, yes. Yes, they are in the same form, because if you notice, the x terms are above each other, the constants are above each other, the equal sign's in the same spot, and the y's are above each other. Even though they're kind of backwards from slope-intercept form, and normally we put our y in front, they are still in the same form. So we can go ahead and start making our zero pairs. We are done with step 2. For step 2, our zero pairs, the x and y variables, neither one of them are zero pairs yet. But I do notice that both my x and y terms are already opposite signs. So I'm just going to look for the smaller number. So I chose to eliminate x. I'm going to multiply my top equation, or my bottom equation, by the 3 and the top equation by the 1. So I just kind of crisscross them. Distribute and multiply across. I get 3x. So the top equation we multiplied by 1. So the equation doesn't change at all. The bottom equation, I multiply every term by positive 3. So 3 times negative 1x is negative 3x. 3 times negative 5 is negative 15. Is equal to 6y. If you're not quite sure where you made your mistake, definitely look at those signs. Most people make their mistakes with signs, not usually arithmetic. Alright, now I notice I have a zero pair that I can eliminate, so I'm ready to combine. 29 and negative 15, those are opposite signs, so you have to subtract. 29 minus 15 is 14. The bigger sign wins, so it is a positive 14. Is equal to, I have a negative 8 over a positive 6. Those are also opposite signs, so I have to subtract. But 8 is bigger, and it's negative, so it's a negative 2y. Divide both sides by negative 2 to isolate that variable. 14 divided by negative 2 is equal to negative 7. Oops. Then you're ready to plug it in. So I picked the equation that didn't have the fraction in it. And I replaced the y with the negative 7 that we just solved for. Simplify the equation. Negative 8 times negative 7, and negative times a negative always equals a positive, so that's how I got a positive 56. Then I subtract 29 from both sides to combine my constants together. I get 3x is equal to negative 29. Oh, you know what? If you were watching because you thought you made a mistake, I made a mistake with my signs right here. It's easy to do. 56 minus 29 is not negative 27. So I'm going to correct that mistake there. It's a positive 27. It is a 27 because they're opposite signs, but it should have been a positive 27. Then you divide both sides by 3. And so x then equals to 9, not whatever I had before. So your final answer should be 9, negative 7. Okay? You might have talked with your instructor when you saw that answer, like, I didn't get that. That's okay. If you talked with your instructor, then he would have corrected my mistake. If you put that in your communication logs, maybe you get some extra credit for that. Alright, let's go ahead and look at number 5. Or actually, yeah, number 5. And I'll do that one with you. If you haven't noticed yet, each one of my example problems here is of the 4 scenarios that you could have. So in problem number 5, we don't have any fractions. The equations are both in the same form. Our variables line up and the equal sign line up, the constants all line up. So we're in the same form. Now we're ready to make our zero pair. This one's really easy. If you look at your y terms, we already have the same number. The only thing we're missing, though, is the opposite sign. So remember, all you have to do with this is multiply the entire equation by a negative, or change all the signs. So I'm just going to recopy it, but the sign of every term, I'm just going to change it to its opposite. Then the top equation, I just recopy it because I didn't do anything to it. So I made my zero pair, that 7y, negative 7y, which can cancel out now, and I'm ready to combine and solve. 14 plus 2 equals 16, which is equal to negative 9 and positive 7. The bigger sign is the negative, and because they're opposite signs, you have to subtract 2x. We're solving for x, so we divide by negative 2 on both sides, which cancels out the 2, so x is equal to negative 8. Go ahead and push pause if you need to copy that. Alright, so what step are we ready for? Plug it in. Alright, and remember, when choosing which one to plug it in, look for the one that has the smaller numbers. So I would use the bottom of the equation. So we replaced my x with the negative 8. Also be careful when you're doing that step. I see students plugging it into the wrong variable. So just make sure if you answered x or found the value of x first, make sure you replace the x variable and not the y variable, and vice versa. So I'm going to simplify this. Add 2 to both sides. 7y is equal to negative 70. Divide both sides by 7. So y is equal to negative 10. Right, write your final answer. Should be 8, negative 10. Go ahead and look through the problem. If you need time to still work it out, you can push pause and finish doing the problem and checking with my work as you go. When you're done, go ahead and push pause and try to do 7 completely on your own. See how far you can get. If you can get all the way to the end and then check your final answer, hopefully it'll be correct this time and you won't have to watch all the steps one more time. Okay, problem number 6. We don't have any fractions. We also do not have, these equations are not in the same form. Look at where the equal sign is located. So on one equation, the top equation, we have the y on the left and the x on the right. On the bottom equation, we have both the x and y on the left-hand side. So we do need to rearrange these equations. I'm going to go ahead and put in standard form. So I want my x term first. It changes to a positive because I just switched the side. The 12 stays positive because I still kept it on the left-hand side of the equation, is equal to, and when I move them over, there's nothing left on the other side, so I just write 0. On the bottom of the equation, I can flip the x term and the y term around, but they don't change their signs because they didn't change the side of the equation. Is equal to 0. Alright, so now that we have them in the same form, we're ready to make 0 pair. And well, it looks like we have our worst case scenario here. We do not have numbers that are the same, and we also do not have opposite sides. So we have to pick a variable to eliminate. Now these coefficients are pretty close, and it really doesn't matter which one you choose. For some reason I decided to choose y to eliminate the y term on this problem. So I multiplied the top equation by 6 and the bottom equation by 12. If you chose to eliminate x, you would have multiplied the top equation by 5 and the bottom equation by 14. Oh, and because it is the worst case scenario where we also do not have opposite signs, you have to multiply one of the equations by a negative as well. So I multiply 6 times 14 is 84. X, 6 plus positive 12 is positive 72y is equal to 6 times 0 is 0. Yes, I used a calculator. It's okay. On the bottom equation, I'm multiplying by negative 12, I'm sorry. Negative 12 times positive 5 is negative 60x. Negative 12 times positive 6y is negative 72y. I already see that order pair is equal to 0. Eliminate my 0 pair, and I'm ready to combine. 84 and 60 is 24, and it stays positive because the 84 is bigger. X is equal to 0. Divide both sides by 24 to get x all by itself. X is then equal to 0. Push pause if you need to still copy. Alright, ready to plug in. I chose the bottom equation, 6y plus 5x. I replace the x with the 0 and equals 0. By the way, I do want to show something. Here's another common mistake. I like showing the mistakes that other students make. We like to learn from other students than to make the mistakes ourselves. I see some students do this. They go 6y plus 5x 0. They do something crazy like that. When you replace a variable, do not rewrite the variable again. Okay, and now I'm solving for y here. That cancels out, so I'm left with 6y is equal to 0. Divide both sides by 6. So y is equal to 0, and that makes our final answer 0, 0. Our two lines must intersect at the origin if it was graphed. 2 more problems. Then I would like for you to go on to lesson 1.4. This is a big lesson, so if you do not get all of it done on day 3, that's fine. Just pick up on it day 4 and wait to do your independent practices then on day 4. Let me do problem number 7 with you. We do not have any fractions in this one. The equations are not in the same form. So I'm going to look at the first equation. I'm going to start my x term, so I write 5x. It does not change signs because it didn't well, yeah, we are kind of changing the side of the equation, so I better put a negative 5x minus 6y is equal to positive 17. Alright, and problem number 7, as you can see, I've already started this. It didn't have any fractions in it, and so I didn't need to do that step. They were not in the same form, so I put them both in standard form. Now we're ready to make our zero pairs, and I do want to show you that other method that I was telling you about. This is not a tried and true method. It doesn't work every single time, but the only reason why I'm going to really show you this is because if we do multiply by the opposite coefficients, we're going to get really big numbers, and you kind of are going to have to get out that calculator or do it longhand. So a shortcut for this, for making our zero pairs, we notice that we already have opposite signs, so it doesn't matter which one we eliminate, the x or the y variables first. But if you look at our y variables, they're not the same. We have 6 and 12, but you could change just one of them to make them the same. What I mean by that is, can't 6 equal 12 if you just multiply it by 2? Alright, so this is a shortcut that you can use. Instead of multiplying by the opposite, if you know the number that would make it a multiple of the other one. So in this case, if we multiply this equation by 2, because 6 times 2 equals 12, the number that we're trying to eliminate, then use that number. That way you only have to change or multiply one equation. Now I ran out of room here. I can move. No, I ran out of room, so I'm going to have to write these down at the bottom. So the top equation, I'm going to multiply by positive 2. Negative 5 times positive 2 is negative 10. Negative 6 times positive 2 is negative 12. Oops, I forgot my x in there. So negative 10x minus 12y is equal to 17 times 2 is 34. Can you imagine if I was multiplying that equation by 12 and the bottom equation by 6? I would definitely have to do. So most of that I was able to just do quickly in my head. The bottom equation we did not change, so you just copy it down. Isn't that a whole lot easier? Now, that trick doesn't work all the time, so that's why I said you can, if you want a tried and true method, multiply by the opposite coefficient. But if you happen to notice that all you have to do is change one equation to equal the other, then you can do that. Alright, so I'm done with those two steps. I made my zero pair right here, and now I'm ready to combine and solve. Negative 10 and positive 9 equals negative 1x, which is equal to 34 and 15. If I combine that, is 49. Divide both sides by negative 1. So x is equal to negative 49. Sorry, that was not negative 49. I made a mistake in there somewhere, and I was going back to go check it, and I accidentally erased the whole page, and I can't get it back up again. So I would have, if I could, see where I went back and try to look for my mistake. So instead I'm going to start over again. I apologize for that. Let's see, let's first make sure the equation's in the right order. Negative 5x So look on what I had already started. Did I start it the same way? Negative 5x minus 6y equals 17. And then the bottom equation, I moved the 9x over as a positive 9x. The 12y stays negative because I didn't change signs. Equals positive 15. I think that's right there where I made my mistake, if I remember right. Yeah, because I don't think I think I had opposite signs before, and now I don't. So I must have had a sign error right there with that negative 12y. Alright, but I am going to use that trick I was trying to explain to you about multiplying just one equation to equaling the other. But because they are the same signs, I do need to make one of them a negative. So I can make it a -2 like this, or I can put the negative down here and saying, okay, I'm going to multiply that whole equation by -1 to make them opposite signs. So I'm going to do that and show you what I get. -10x -12y is equal to, is it 34? Yeah. The bottom equation I'm multiplying by -1 or the negative, so I just change all the signs. -9x plus 12y is equal to -15. Now I have a zero pair and I can combine. -19x is equal to 17. I'm really messing up with this problem, aren't I, today? Just a second. Not 17. That would be 19. Okay, now I'm back on track here. Divide both sides by -19. Divide by -19. So x is equal to a negative over or a positive over a negative is a negative. 19 over 19 is 1. So x is equal to 1. Now I'm ready to plug it back into one of the original equations. So I'm going to use the top one. 6y plus 5 times -1 plus 17. Quite a bit of simplifying to do over here. So 0 equals 6y. Let's simplify all of this. Remember your order of operations though. 5 times -1 is negative. That's -5 plus our 17. So that equals positive 12. Let's isolate our variable from the constant. So we get -12 equals 6y. Divide by 6. Divide by 6. So y is equal to -2. That means our final answer for problem 7 should be -1, -2. Okay. So see if you can use that trick on number 8. I'm trying to remember myself what the problem looks like. Oh, 8's a piece of cake. You don't even have to do that. Go ahead and do number 8. I'll give you a few minutes. Go push pause, and when you're done, I'm just going to show you the answer, not the work behind it. If you don't get that final answer for problem 8, then please go sit down with the instructor and have them help you work through it, or see a tutor, and we'll see how you get the final answer. These problems do take quite a bit of practice, and until you finally get them. As you can see, it's real easy to make just one little mistake, and then that just gets the whole problem wrong. So work carefully and slowly. Definitely use grit here, perseverance. You can get through it. That's why there's going to be fewer problems on future worksheets. These problems in algebra are going to start to get longer and have more steps to them, so you're not going to have quick little fast solutions all the time. Alright, go and push pause. When you're ready, push play, and I'll show you the answer. Okay, you should have gotten an answer of 3, 0. Alright. Ask your instructor if you think you need more practice before you do your independent practice. I'm sure he'll be able to find some for you.